You might have heard the buzz phrase application containers, but what is it and why do we care as it relates to security? So we're going to answer both of those questions. Let's start by having an overview of what an application container really is and why it's used. So the idea is that we want to have application components. Now, what does that mean? Well, a larger application usually really consists of smaller specialized modules. For example, a complex web app might have a function to print and save to PDF. Well, that function, print and save to PDF, is one module perhaps that might be running in its own application container. An application container is just a logical boundary that houses application components. Now, we call these containers microservices. They are small modular task-specific functions that together as a whole comprise a more complex, larger application. Now, the idea with this is that we are decoupling application components from relying on a single large monolithic app. That's a lot of words. A monolithic app is one big giant program that isn't broken down into small components. Well, that's not how things are done anymore with modern software. We are using smaller components and they are running in containers much of the time. Now, the contents of a container are application files, and we can even enable things like web servers within just the container. And that can be accessible over a port like port 80 normally allows you access to a web server. So let's talk about this by looking at a diagram. Pictured in our diagram, we have a host operating system. So that could be Windows, it could be some variant of Linux or Unix. After that, we have to install some kind of an engine that understands what containers are and can run and manage them. One of the more popular engines is called Docker. So let's say that we've installed the Docker engine on a server, whether it's Windows or Linux, doesn't matter. What we can then do is run multiple application containers. In our diagram, they're labeled as App A through to App F. Each of those is a separate single entity, an application container. All of those containers might work together for a larger app, or they might be completely independent. Now you might say, wait a minute, that looks like virtual machines. Not quite, because virtual machines contain an entire operating system. Application containers don't. All they contain are the files to run the app, no operating system files. What's interesting is they start up super quick. Containers start up quickly because the OS is already running. It's the underlying host operating system. Unlike a virtual machine, we don't have to sit and wait for the OS to start. It's already running. The app container actually shows up just as a running process within the underlying host OS. Software developers love this and it makes sense. I need to quickly make changes to code and test it for quality assurance and make another change and test it. It's so quick and easy to bring a container up and down compared to a virtual machine. So that's the idea. We have all of the files that are required for that app or that app component contained within that application container. Now let's take a look at how we might manage containers in Linux. So here in Kali Linux, I'm going to start by installing Docker. I'll use the command sudo apt install docker.io. Now at this point, it's going to reach out to package repositories on the internet that are configured for this Linux distribution, and it asks me if I want to continue installing, so I'll type the letter Y. I'm going to press enter. I want to run Docker. Now what we're going to have to do once Docker is installed is we're going to have to start the Docker engine. It's a service. So once we do that, we can then start working with application containers. So now that Docker is installed, we need to start the Docker service engine. So I'm going to clear the screen. I'm going to run sudo service docker start. Now once that's done, I want to verify that it's running. So I'm going to use my up arrow key to bring up the previous command, and I'm going to change start to status. I want to see the status of that background service, which is really called a daemon in Linux. And it looks like it's active and running. Good stuff. Q for quit to get out of that. Let's move on. Let's start working with Docker. What I'm going to issue, let me type in the command and I'll explain it then. sudo docker pull alpine. What on earth is happening? Okay. Well, the Docker engine, unless you tell it otherwise, it's going to look for container images, application container images on Docker Hub online on the internet, where there are thousands of application containers. So there's one I happen to know of that's called Alpine. It's a little application container that allows you to configure some Linux settings. So it's not a Linux OS, okay? Because if it were, it would be a virtual machine. It's going to use the underlying OS to actually execute. Okay, so I'm telling it to pull down a container image called Alpine. Fine, let's press enter and let's do it. Now, after that's done, I'm just going to verify that that image is now available locally on my machine. Now, when I say image, I mean a container image that you can launch a container from. So I'm going to type Docker images. Actually, I'm not. I'm going to run sudo Docker images, elevated permissions. And so what we get returned is the fact that, yeah, the Alpine container image is now available locally because we just pulled it down from Docker Hub. That's implied by default. Okay, so now what do? You run the container. So I can do that with sudo docker run, in this case, -it. I means I want to run it in interactive mode, and T means I want a terminal. I want to interact and browse whatever is in that container at the file system level. And what is it called? Well, the container is called Alpine. Enter. So what happened is it just started the Alpine container, just like that, very, very quick. And I'm given a Linux prompt that doesn't look like the Linux prompt I was at originally, because I'm actually in the application container. Well, remember we said that an application container only contains files related to that app, like binaries or DLLs or config files. Let's see what's in it. ls for list. Here I see a bunch of subdirectories. That's not on my Kali Linux host. That's within that container only. So I can browse the file system, add files, delete files, make configuration changes, whatever I need to do, which is going to be specific to that app. But what I want to do at this point is exit out of that to stop that container. That's one example. Let's do another example of a container, except this one is going to have a little web server stack and a sample website within it. That's common these days. So I'm going to run sudo docker pull. I want to pull from Docker Hub online. And I happen to know there's a little container image called Caddy, C-A-D-D-Y. If I don't know that, I can go to Docker Hub in my browser and search for whatever I want. So once again, it's just going to pull it down. These are small containers, luckily. They can get very big sometimes. It's done. Like we did before, if I run Docker images, again, if I run sudo Docker images, it shows me now that I have not only the Alpine container image, but also Caddy. Okay, so I think I remember what to do here. sudo docker run, right? To run a container from an image. Now in this case, I don't want to interact with it. I just want it to run in the background and just, you run and give me my command prompt back. So -d for that. Next, -p, because I know that this one has an HTTP web server on port 80. And what I want to do is map port 80 in that application container to port 80 on the host where that container is running. So it's accessible outside of this machine on port 80. So -p, then 80:80. I'm mapping port 80 on the host to 80 in the container. And then the name of the container image I want to start, Caddy. Okay. So it's running in the background, and I can verify that with docker ps, or of course sudo docker ps elevated. Now what I want to do is I'm just going to connect to the IP address of this Kali Linux host. If I do ifconfig, I will see what that is. So the IP address for this host is 192.168.4.108. Why don't we connect to that in a web browser to see what pops up? Okay, so when I go into a web browser and enter the IP address of the Docker host, it's returning a web page for Caddy. So I'm actually running a mini web app in that container. Now you saw how quickly that loaded. It loaded as quickly as I could press enter, essentially, way quicker than if we had a dedicated virtual machine hosting a custom web app. Now, what does this have to do with security? if you don't understand how this works, it can be very difficult to harden your environment. Imagine that you're running a vulnerability scan on your network and it shows that there's something listening on port 80 on this host. But then when you go to examine that Linux host, there's not even a web server stack installed. Well, wait a minute. When I ran a scan, port 80 was listening. Where'd it go? It's running in a container. But if you don't understand how containers work and how they interact with the OS, that would be very difficult to find. And as a result, you wouldn't be able to harden your environment. Now, we can also run containers in a cloud computing environment. They can be deployed into a cloud-based virtual network, which leads into software-defined networking, or SDN. All that this means is that it makes it very easy using a GUI or command line to configure network settings without knowing the underlying complexities for the actual equipment. I don't know, let's say, how to program a Cisco router or a Cisco switch to create a VLAN, but I know how to use Microsoft Azure or Amazon Web Services to very quickly create a virtual network in the cloud. So SDN is kind of an interface that sits between making it easy for users to create those network components and the underlying equipment actually doing it.